Now, what about all of these data types? Well, here's a quick summary. Within the world of SQLite, these are really the data types you have available to you. And it's not that many. There is our integers for simple numbers, counting up or down. There's numeric, which are numbers, but things like dates and years and time. So things that are composed of numbers, but are a little different semantically. There's real, which are floating point values with decimal points. There's text, which is just text. And then we haven't seen it yet, but there's blobs, which is wonderfully named. And it stands for binary large object. It's like when you want to just store raw zeros and ones for some reason in the database, so that's not an especially common case, at least for our purposes, vis-a-vis these others. But there's these other keywords we should keep in mind, some of which we've already seen, like null and not null, which allows you to specify when creating a table what kinds of values can or cannot be there. And this is how a relational database differs from something like a spreadsheet. Generally speaking, in a spreadsheet, there is nothing stopping you from typing or deleting any values whatsoever from any of the rows and columns. In fact, it's pretty easy for you or a colleague to break a spreadsheet in that way. But one of the features you get from a real-world database like SQLite is that the database software itself can prevent you or other people, colleagues, users, from removing or adding data to your database that should not be there. You can specify that this column, this cell in our database table cannot be null, or it can be null, and you can specify that it must be unique, or it doesn't have to be unique. The database gives you those features for you. And indeed, these things called primary and foreign keys are the key to, no pun intended, relating one table's data to another table's data. So let's go ahead and start playing around with some of this real world data here. Let me go back to VS Code and let's poke around. If I now do select star from ratings, let's go ahead and look at like some of the most popular TV shows over the years. Now, if I just hit semicolon and enter now, that's going to give me all the ratings, and that's not that useful. But let me do this. Let me add a where clause, which we saw earlier, and say where the rating is greater than or equal to maybe 6.0. So it's better than 5, so it's at least 6 or higher. I don't really want to see hundreds or thousands of results, but let me go ahead and just limit this to like the first 10. It's not necessarily the top 10, because I'm not ordering the data, but just for the sake of discussion, I want to see 10 shows that seem to be pretty good based on their rating. All right. Not that useful, because what the heck are these shows? These are all unique numbers. I don't see the office's number in here, but I do see 10 show IDs that I haven't yet seen. Well, this isn't all that useful yet, but let me whittle this list down. Instead of selecting everything, let me re-execute that same query, but select just the show ID from ratings. Enter. So same kind of query, but a subset of the answer that I get back. I just have now a temporary table containing all of those show IDs. Well, why is this useful? Well, what I don't want to do is this. If I want to know what 10 TV shows should I start watching, this would be incredibly tedious. Select star from shows where the show's ID equals, and I'll copy paste this, 62614 semicolon. Enter. Okay, so that's the first TV show that debuted in 1981 that has a pretty good rating of 6.0 or higher. What's the next one? Well, let me start with that same query, but go back up here and copy the second ID, semicolon. All right, Catweasel, so from 1970. That seems to be pretty popular. Let me do it again. Let me delete that ID, grab a third ID here, copy paste it, enter, UFO from 1970. I mean, this is going to take me forever just to come up with my list of 10 TV shows that I should watch based on their rating. So there must be a better way. Copy paste is rarely, if ever, the solution to our problems in CS50, let alone programming more generally. Can I automate this process somehow, but in a way that shows me useful information? Because I, as the user, I really don't care about the primary keys, the foreign keys, any of those integers. Who cares? They exist solely for the purpose of uniquely identifying data in a database, but I am a human, and I prefer to think about TV shows by way of their titles. So how can I do this? Well, let me go back to that earlier query whereby I got all of the show IDs that are rated at least 6.0 or higher. Done. And now let me use this as kind of a building block to answer another question as follows. Let me do this. Select star from shows where the ID of the shows is in this earlier query. So here I'm going to copy paste, but just to save myself some keystrokes and make clear that I'm indeed using the same query as earlier, I'm going to copy everything from earlier, paste it here without the semicolon, and I'm going to move the limit 10 to the outside because what I care about is limiting the number of TV shows, not the show IDs per se. So it's almost the same, but just like in math class, because of the parentheses, this is going to be executed first by the database. That's going to give me back a list of IDs where the ratings are greater than or equal to 6.0. And then I'm going to use that list of IDs to ask the database a second question, the outermost question here. Give me everything you know about the shows whose ID is in that list of results. So I'm using one query inside of another. This is known as a nested query. And we do this all the time in C and Python. When you pass the output of one function into the input of another, that's all we are doing here. So when I now hit enter, what I should see is, thank you, actually 10 shows titles, not to mention their IDs and their year and their episodes. And indeed, notice the title, notice the IDs at left. Those are the IDs that we selected earlier, but thankfully I can see the titles now as well. And if I don't care to see any of that other information like year and episodes, that's fine. Let me just hit up again. And instead of selecting star, let me just select what I care about. All I care about is the top 10 TV shows that I should watch here. And now I have just the titles as well. So again, even though the queries are getting a little longer, and I could be a little more tidy and I could move things to the next line and so forth, and I'll do that as an example, but it's just composing ideas from earlier into larger and larger queries by solving smaller problems first. And let me do this now. Let me actually type this out a little more clearly without wrapping. If in SQLite, whoops, let me do this. Let me go ahead and make this multiple lines. So if I were to start this query as follows, select title from shows where ID in, but I know what I'm going to type is actually going to wrap onto multiple lines, that's OK. I can hit enter here. Notice my prompt changes to an ellipsis, dot, 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 and then the greater than sign. This is SQLite waiting for more of my query. So I'm going to go ahead and copy paste it from earlier. And then I still haven't hit semicolon. I'm hitting enter just to put it onto another line. But now I want to limit it to 10. And now semicolon. So I mention this because it's actually very easy to accidentally get into a weird place with SQLite, because if you have an open parenthesis or an open quotation mark, you might get the dot, dot, dot prompt, which just means you haven't finished your thought, at least as far as SQLite is concerned. So you can finish your thought with the semicolon, the parenthesis, the quote mark, hit enter, and now you have a 3-line command, which might just be a little more readable for you, but still executable. Worst case, if you get into a weird place, Control-C is your friend to interrupt the process somehow, to actually quit out of that query itself. All right, but there's a way now to do this differently. And I used this terminology earlier. Wouldn't it be nice if, even though we have a shows table and a ratings table and all these other tables, could we somehow join them back together when we want to see more data at once? And indeed, if we consider in SQL one other keyword, we can do exactly that. An operative word in SQL is that of literally joining 2 or more tables together. So what do I mean by this? Well, let's do this visually first. So here we have a visualization of a TV show at left and the rating thereof at right. And for today's purposes, I don't really care what the actual rating is or the votes were or so forth. So I've showed just a subset of the data herein. But these are 2 separate tables, shows at left and ratings at right. But notice, even though this is a tiny example, notice that they do have a column in common. Notice that the ID value at left is the same as the show ID at right. Wouldn't it be nice if I could kind of take these tables then and kind of line up those identical values and concatenate them together by kind of joining them where those IDs are the same? And in fact, just for the sake of visualization, let me propose to do this. All I did was flip the title and ID column, not because this is technically useful, but visually it puts the 2 IDs up against each other. In fact, let me squeeze the tables closer together, noting that 386676 is indeed the unique identifier, and it's the same in both the shows table and the ratings table. So sure, let's kind of shift things over. And heck, I don't really need both of these values here at the same time, so I bet I could somehow literally join these 2 columns together in code. In fact, let me go back to VS Code and let me introduce one other technique here. Select star from shows, join ratings. How do I want to join those 2 tables, left and right? Well, please join them on the shows table's ID column equaling the ratings table's show ID column. And, just for good measure, where the rating is greater than or equal to 6.0 and limit 10. So the last part there is not that useful. It's just borrowing some of the ideas from earlier. What is useful here is I'm not just selecting from one table now. I'm selecting from two tables being joined together. But I have to tell the database, how do you want to join those together? Like, how should those two tables be lined up? Well, I want the show ID column in one to line up with the I want the ID column in one to line up with the show ID column in the other. So you have full control over what values are being lined up. And if I hit enter, I will see everything together here. The ID column, the title column, the year of the episodes, and also the duplicate show ID column, rating columns, and vote columns, which is pretty much what we just saw. But my own visualization, I was keeping it simple, ... I don't care about most of those columns. But this is what we have done. With this join keyword, we have created in memory a temporary table that has all of that data I care about and, in fact, a bit more. Now, at the end of the day, what I really only care about, if I go back to my visualization here, is I really only care about getting access to, say, the title and the rating itself. So if I want to whittle this list down even further, that's actually not that hard. Let me go back to VS Code. And as always, instead of just selecting star, let's select what I actually care about, like title, comma, rating. And if that's all you want, so long as it's clear to the database that, OK, titles from over here and ratings from over here, so long as the column names are not duplicative, I can just refer to them by their short names, enter. Now I get back 10 TV shows that I do want to watch, because all of these have ratings, as you can see with your eyes, that are greater than or equal to 6.0, and there are the titles thereof. So let's return now to the schema for the entire database, focusing not just on the shows table and the ratings table, but a few others as well. In particular, why don't we focus this time on the genres table, which describes whether a show is a comedy or a drama or something else along those lines. So let me go back to VS Code here, and let me go ahead and wrap my mind around this new table. So select star from genres, and then let's just limit 10. I don't really care about everything that's in this table, just want to get a quick sense of it. Okay, it's actually a pretty simple table, per the diagram from a moment ago, whereby the genres table has two columns, a show ID and a genre. And the show ID presumably refers to the ID column in the shows table, and genre appears to be a text field that describes the genre for that particular TV show. What's worth noting about the genres table is that this is not really practicing what we preached earlier, because indeed, I see comedy, comedy, comedy. I see it 3 times. I see sci-fi twice. So there is redundancy in this table, so feels like a missed opportunity to fully normalize these tables by removing those duplicates and having a whole separate table, much like we have a whole separate table for shows and for people themselves, but more on that perhaps another time. For now, let's go ahead and just focus on one of these TV shows that we saw earlier, that of Catweasel, one of those earlier UK shows. Let me go ahead and do select star from shows. Let's do select star from shows, where the ID of the show is this one here. Notice that what's curious about this show here, 63881, is that it's a comedy, an adventure, a comedy, and a family show all together. Now, I happen to know what this one is, but as before, let me go ahead and select it by its ID, where ID equals 63881, semicolon, and indeed, there's the Catweasel show that I've promised us. So it seems that Catweasel, per the genres table, actually has many genres associated with it. And this is worth noting because indeed, besides one-to-one relationships across tables, you can also have one-to-many relationships, whereby in this case, one show can have many genres associated with it. So to see this, let me go back to VS Code here. Let me clear my screen and do .schema for genres just to make sense of what's in there. And as expected, show ID is an integer that can't be null, that is apparently indeed a foreign key that references shows table's ID column. So quite like the ratings table, but the genre in here is indeed a textual value for which there might be duplicates, but it can never be null. All right, let's go ahead now and see if we can't select programmatically the genres for this TV show called Catweasel. Let me go ahead and first select the genre from the genres table where the show ID equals that same value. Okay, there's that list of 3 values that I inferred by just looking at the top 10 list earlier. But indeed, this show, 63881, aka Catweasel, has 3 genres: adventure, comedy, and family. So how can I go about selecting now the genres, plural, for this show, well, frankly, I and no one in the world should really have to know what the unique identifier is for Catweasel. After all, if you were to go to imdb.com, it would be a bit crazy to have to type in the numeric identifier for a TV show just to search for it. So let's make this more like a keyword search. Let me instead say, select the ID from the shows table where the title of the show equals, quote unquote, Catweasel. In other words, I know from earlier, using select alone, I can get that unique ID of Catweasel. And I know from earlier that I can compose more sophisticated queries by nesting one select inside of another. So let me do this. I'm going to copy this just so I don't have to type it all out again. And let me go ahead now and select the genre column from the genres table where the show ID in question happens to equal the results of this query. And now notice a subtlety. Previously, when I nested a query, I actually used the preposition in because I was getting back a whole bunch of show IDs, and I wanted to get back the title of any show whose ID was in that list of IDs. In this case, Catweasel, by definition, only has one unique identifier, 63881. So instead of saying in, I'm more precisely saying equals. I want to select the genre for the show that literally equals this value. And SQL will accommodate that. So you use in when you want to search across multiple values, and you use equals when you know there's just to be one. If I hit enter, there we have it. I now have a query that, much like my first query, searches for all of the genres for the show, but it doesn't arcanely search by a show ID. It instead searches by the name of the show itself, which I'd argue is much more useful. Now we can visualize what might have just happened. Here are simplified versions of these two tables. We have the shows table at left and the genres table at right. And just for the sake of discussion, let me flip around the two columns just so we can see that these two things do line up, even though this is not a technical thing. Let me kind of highlight the fact that 63881 indeed appears everywhere among these IDs. So let's kind of nudge things closer together. And let's go ahead now and ideally line up all of these common values. But notice here that it's not a one-to-one. This is kind of a one-to-three relationship, more generally known as a one-to-many. So really, when we line these columns up, what's actually happening, when you line these tables up, what's really happening is something like this. Select star from shows. Let's join them together on the genres, with the genres table on shows.id equaling genres show ID, where ID equals 63881. So what have I just done here? Well, if my goal is to sort of join this stuff together, these tables together, as we did earlier, not using ratings but genres, but we want to accommodate for a one-to-many relationship, the query is essentially the same. Select everything from the shows table by joining it with the genres table. How to join it? We'll join it on the shows.id column and the genres.showID column. So that's what I mean by kind of lining them up just right so that those numbers overlap. But for the sake of discussion, I only care about one TV show for today. I could do this for all of them, but let's focus on just one. And when I hit enter now, notice what happens is I get, per the star operator, all of the columns from both of the tables, including ID, title, year, and episodes, but also show ID and genre. Now, the database itself, it's not bothering to flip things around and show me side by side like I did with my slides, but the idea is exactly the same. When I try to join these two tables in this way, what's effectively happening is the database is noticing, okay, I've got a value at left, 63881, and I got the same value at right again and again and again. So effectively what's happening is the left-hand table's rows are duplicated verbatim, just so that when we get back a table, it has the same dimensions, rows and columns. Height and width sort of work out to the same. That does mean there's a lot more duplicative data that's coming back. But if you want to be able to see everything about Catweasel for each and every of its genres, this, in this case, is what the join query would be doing. We get back, yes, duplicate data, but it's fundamentally joining things in precisely the same way. Now, at the end of the day, I probably only care about, really, the title and the genre, so I can tighten this up. If I go back to VS Code here, and I select only title, comma, genre, from shows joined with genres on shows.id equals genres.showID, where the ID is 63881. I'm just going to give back a much smaller table, exactly like the one I depicted a moment ago. And heck, if that's even too much, like I don't need to know the name of the show if I'm already searching for it, well, let me hit up. Let me go to the beginning of my query, and let's just get rid of title and genre and just select the genre. And now I have a list in this temporary table of all of the genres for this particular show. If we bounce back, meanwhile, to the chart itself, to the schema itself, there's even more tables than these. And in fact, we won't spend time going through each and every one of them, but I think it's probably worth showing one of them that really represents a third and final type of relationship that you might have in this or any database of your own as well, a many-to-many relationship. And indeed, that's the right semantics for something like TV shows and TV stars, because presumably one show has many TV stars, and one TV star is presumably, if they're successful, going to be in many TV shows. And so you sometimes want to have not a one-to-one, not a one-to-many, but a many-to-many relationship. And to do that, it does not suffice to have just two tables, like shows and ratings, or shows and genres. You might need a third table. And this is where we began after the break by visualizing things in that spreadsheet temporarily when we have a shows, we have a people table, and maybe we have a stars table that somehow relates the first to the second. So how can we go about building that? Well, let me propose that we explore the data set as follows. Let me go back to VS Code, and let's just start to poke around with The Office again, one of my own favorite shows. And let's do select star from shows where the title of the show equals quote unquote The Office. Let's just see what we know about the TV show The Office. Now, as some of you might know, The Office in the US, with which I'm very familiar, is not the only version of The Office. In fact, the origin for it was actually a UK version several years prior. But I think the one that I'm most familiar with in the US is probably this one that started in 2005, if only because it had 188 episodes, because it ran for like 9 years, 9 seasons. So that's probably the one I'm thinking about with Steve Carell, Rainn Wilson, and others. So if I want to narrow my search results to that, let me start with the same query, but say where the title is The Office and the year equals 2005, because I, for today's purposes, just want to focus on one of these here offices. Now, suppose I wanted to ask a question like, who starred in The Office? Now, that question is very reasonable. And honestly, if you go to imdb.com and search for The Office, you'd probably expect to see a list of all of the TV stars in that show, the cast members. But this data seems to be split across a shows table, a people table, and a stars table. So how do I get back a simple, common question, given what I'm proposing is very good database design? Well, let me propose that we take baby steps here, or small bites out of this problem, as always. Let's first select, how about the ID only from the shows table, where the title of the show is The Office, and the year of that show is 2005. I don't care about all of the columns. I only care about the ID. And I could make mental note of 386676 and then copy paste that. But again, that's not the right way to do things. I should not be hard coding the IDs literally when the user is going to care about the titles, not these IDs. But suppose I want to now get everything I know about that show as it relates to people. Well, let me go back to the schema for these three tables. Notice that we have the shows table here, which has an ID, a title, a year, and number of episodes. The people table has an ID, a name of a person, and their birth year. But this stars table is what we might call a join table, whereby its purpose in life is to implement this relationship between one and the other. And that table clearly has a show ID and a person ID. And this is where I'm now thinking. In my current query, I am getting the show ID that I care about. What I really want to know is who starred in this show, so I need a bunch of person IDs. Well, this is the table, the stars table, that associates show ID with person ID. So maybe I can kind of bootstrap things and use this one show ID that I just found all of the corresponding person IDs, and see where that gets us. So let me go back to VS Code, and let me do this. Select all of the person IDs from the stars table where the show ID itself from that table is equal to, and now I need this query from earlier. So let me go ahead and do this maybe on a second line. Select ID from shows where title equals The Office and year equals 2005, close parenthesis, semicolon. In other words, I've got a nested query again, per my parentheses. I want the unique ID for the office. Then I want to use that show ID to find all of the related person IDs. Enter, and I get back a whole bunch of person IDs. But who are these people? One of them is probably Steve Carell, one's probably Rainn Wilson, and so forth, but this is not useful information. So let's take this home one step further. Let's select the name from the people table where the ID of that person is in the following query. Well, how do I get back all of those people IDs? Well, person IDs. Let me go ahead and do select person ID from stars where the show ID equals, and now let me do another nested query. Select ID from shows where title equals, as before, The Office, and year equals 2005, close parenthesis, semicolon. So this must feel like a lot if you're seeing SQL for the first time, but realize that I'm just taking a third and final baby step. The first query I ever executed during this process was the last one on the screen here. Give me the ID of the office that I know and love from 2005. The second line of code on the screen is the second command that I wrote before, whereby I want to select all of the person IDs from the stars table that are associated with that show ID. But that just gave me a list of person IDs, none of which I recognized visually. So the third and final step, which on the screen is the very top line here, select the name from the people table where the ID of that person is in that list of person IDs that I didn't recognize earlier. So if I didn't make any typos and I hit enter, I should see, thankfully, Creed Bratton, Steve Carell, Jenna Fischer, Kate Flannery, and so forth, some of the top stars from their version of The Office. So a big query to execute, but composed of smaller and hopefully seemingly simpler queries as well. All right, let's try one other query, not just searching for all of the stars of the TV show The Office. Let's just search now, conversely, for all of the TV shows that Steve Carell was actually in. So one way I could do this is very similar in spirit. Let me go ahead and select the title from the shows table where the ID of the show is in the following list. Select the show ID from the stars table where the person ID equals, and now I need Steve Carell's own ID. So much like I search for the office's ID, let me search for Steve Carell's ID as follows. Select ID from the people table where the name of the person is, quote unquote, Steve Carell. Close parenthesis, semicolon. So same idea, but I'm sort of searching the tables in the opposite order to get back all of Steve Carell's shows instead of all of the Office's TV stars. Let me hit enter, and I get back all of the shows, according to IMDb, that Steve Carell has been in. But turns out there's another way to do these kinds of queries when you do have 1, 2, 3 tables involved. You don't have to rely on subqueries alone. If you prefer the idea of kind of joining the tables, not just 2, but 3 of them, you can do that as well. Let me do it as follows. Select title from shows joined with the stars table on shows.id equaling stars.showid. Joined once more, so we're sort of combining all 3 tables at once in your mind's eye, the people table on stars.personid equals people.id, where name equals Steve Carell. Now, this is a different approach where I'm explicitly joining 1, 2, and 3 tables based on those common primary and foreign keys, but it's using the join syntax this time to get back all of Steve Carell's TV shows. And that was actually a little slower because it turns out there's some final opportunities we're about to dive into to optimize this database for faster queries. But let me show you one last way too. If that felt a little verbose, we can also search for all of Steve Carell's shows as follows. Select title from shows, stars, and people. In other words, you can tighten up a join query and specify all at once the 3 tables, in this case, that I want to select things from. And I don't even need to explicitly use the join keyword. I can do it implicitly by saying where shows.id equals stars.showid and people ID equals stars.person ID and name equals Steve Carell. In other words, this is just a third way to express the exact same idea. Give me all of the titles from all of the shows that Steve Carell has been in, joining them really implicitly by specifying which of the columns in one table must equal the columns in other tables. Enter, And I, again, with some suspense, get back now the same list of shows. Before we move on, let me summarize here that we have not only the tables we've looked at, but even one other as well, namely the writers table. And if we're curious as to what that is, we can actually poke around too. If I go back to my SQLite terminal and I do .schema writers, you'll actually see that the writers table is quite similar to the stars table. Because recall that the stars table associated people with shows, so does the writers table associate people with shows as well. But as per this one, we have a show ID and person ID, but the table name itself, writers, connotes that the relationship therein is indeed that of writers. As an aside, there's probably a better way to implement even that idea, because what about directors and producers and other people on a set? Well, more on perhaps that design opportunity another time. For now, I think it's timely where we try to chip away at the time of these queries and perhaps others. So it turns out, besides just deciding when making your own relational database, whether it's with an automated .import command or manually, as we, the staff, did in advance for the IMDb data that we downloaded in files from the internet, we can structure our data in the computer's memory in a way that draws inspiration from week 5 of CS50 and week 3 of CS50, wherein we focused on data structures and algorithms, respectively. In the world of databases, you, the database designer, can choose in advance to create indexes, so to speak, on your own database.